Here are more data science interview questions along with explanations and example answers. 11. What are some common distance metrics used in clustering algorithms? Answer. Common distance metrics include Euclidean distance, Manhattan distance, and cosine similarity. These metrics measure the similarity or dissimilarity between data points in a feature space. 12. Explain the concept of feature engineering and provide an example. Answer. Feature engineering is the process of creating new features from existing data to improve model performance. An example is creating a word count feature from a text dataset, which can be useful in text classification tasks. 13. What is the purpose of exploratory data analysis, EDA? Answer. Exploratory data analysis aims to summarize and visualize data to understand its underlying structure, identify patterns, and uncover insights that can guide further analysis and modeling. 14. How does the k-nearest neighbors, KNN, algorithm work, and what are its drawbacks? Answer. KNN classifies data points based on the majority class of their k-nearest neighbors in feature space. Drawbacks include high computational complexity and sensitivity to the choice of k. 15. What is the difference between precision and recall? Answer. Precision measures the accuracy of positive predictions made by a classifier, while recall measures the ability of the classifier to correctly identify all relevant instances in the dataset. 16. Explain the concept of a decision tree in machine learning. Answer. A decision tree is a supervised learning algorithm used for both classification and regression tasks. It recursively splits data into subsets based on feature values to make predictions. 17. What is the purpose of one-hot encoding in preprocessing categorical data? Answer. One-hot encoding converts categorical variables into binary, 0-1, vectors, where each category becomes a separate binary feature. This is done to make categorical data suitable for machine learning algorithms that require numerical input. 18. Can you name a few dimensionality reduction techniques? Answer. Besides principal component analysis, PCA, other techniques include T-distributed stochastic neighbor embedding, TSNE, linear discriminant analysis, LDA, and autoencoders. 19. What is cross-entropy loss, and why is it commonly used in classification problems? Answer. Cross-entropy loss measures the dissimilarity between predicted probabilities and true labels. It is commonly used in classification because it encourages the model to make more confident predictions. 20. How does a random forest differ from a single decision tree? Answer. A random forest is an ensemble of decision trees. It reduces overfitting compared to a single decision tree by averaging predictions from multiple trees and introducing randomness during training. 21. Explain the concept of bias in machine learning models. Answer. Bias in machine learning refers to systematic errors in predictions that result from the model's inability to represent the true underlying relationship between features and the target variable. 22. What is the curse of dimensionality, and how can it be mitigated? Answer. The curse of dimensionality refers to the challenges that arise when dealing with high-dimensional data. It can be mitigated through dimensionality reduction techniques, feature selection, or using algorithms robust to high dimensions. 23. What is the difference between batch gradient descent and stochastic gradient descent? Answer. Batch gradient descent updates model weights using the entire training dataset in each iteration, while stochastic gradient descent, SGD, updates weights using one data point at a time. SGD is faster but has more noise in its updates. 24. What is a p-value in hypothesis testing, and how is it interpreted? Answer. A p-value represents the probability of observing a result as extreme as, or more extreme than, the one obtained under the null hypothesis. Lower p-values suggest stronger evidence against the null hypothesis. 25. Can you explain regularization techniques such as L1 and L2 regularization? Answer: L1 regularization. Lasso adds the absolute values of model weights as a penalty, encouraging sparsity. L2 regularization. Ridge adds the squares of model weights as a penalty, preventing weights from becoming too large. These additional questions cover a wider range of data science topics, including machine learning, statistics, and data preprocessing. Be prepared to provide detailed explanations and, if applicable, examples from your previous work or projects during your data science interviews.